So a cool thing about inequality statements is I can combine multiple inequality statements to create what's called a compound inequality. And we're going to be looking at a couple of those today. So first off, we need to talk about the distinction between and or. Okay, in math, this is a really big deal. So if I say, um, for example, I am going to bring in pizza and ice cream. I'm going to get you pizza and ice cream. Okay, think about what you expect. You would expect that I show up with both pizza and ice cream. So, an and statement means that both sides of the and statement have to be true in order for the whole thing to be true. An or statement, on the other hand, uh, if I said, I'm going to bring pizza or ice cream, I could show up with both, and that would be quite excellent. Um, but at the very least, you expect me to show up with at least one of them, right? You expect me to show up with pizza or ice cream. Either one would satisfy that statement, okay? I could bring in both, and that would be pretty cool too. So, we're going to look at essentially that same idea, but with inequalities. So if I'm looking at this statement that says x is greater than 3 and x is less than 8, okay, let's think about what part of the number line that falls on, okay? So if I pick a number that's in between 3 and 8, say 5, okay? Well, 5 is bigger than 3 and it's less than 8, so that means that it must be the part in between. If I shade in between, that must be true. So if I were to graph this, we're going to use open dots because it's greater than, less than, you know, I can't touch, I can get really close. And we're going to shade in between because all of these values in between 3 and 8 would make this true. Now, a cool thing about and statements is I can write it as one line. So instead of saying x is greater than 3 and x is less than 8, I could write this as a statement that's one line, one single statement with x in between. So x is in between 3 and 8 here. So I would put the 8 on one side and the 3 on the other, right? I'm allowed to flip these inequality statements around. So x is greater than 3 is the same as saying 3 is less than x. So that's just a nice little feature of an and statement. If we were to think about writing this in interval notation, so remember with intervals, we're going to use parentheses in the same context that we draw the open dots for, and we use brackets when it's something we can touch, or when we would use closed dots. So I have two open dots here. So if I were to put this in interval notation, it would be parentheses 3 to 8. Okay, so my interval, it looks a lot like a coordinate, right? It looks a lot like an xy coordinate, but it's not. Okay, this is saying that I start really close to 3, can't touch it, and I go up to almost 8. Right, I can get really close. Okay, let's look at an or statement. So an or statement, x is less than or equal to -2, or x is greater than 4. So think about what parts of the number line this would satisfy. Now remember, with or statements, we only need one of them to be true. Okay, so if I'm on the left side of the number line, between -infinity and -2, does that satisfy either of these? Well, it satisfies this first statement. X is less than or equal to -2. So everything to the left of -2, I can shade. I'm going to use a closed dot because less than or equal to means I can touch -2, and I'm going to shade everything to the left. Okay. Um, let's think in between -2 and 4. Okay, in between -2 and 4. So if I pick 0, that's not less than -2, and it's not bigger than 4. So I don't think anything in between these two values would work as a solution. Okay, what about to the right of 4? If I pick a number like 5, right? If I pick a number like 5, well, 5 is not less than or equal to -2, but it is bigger than 4, so that would work. Okay, I'm going to use an open dot because I can't touch 4, but I can get really, really close, and I'm going to shade to the right. Okay, now unlike an AND statement where I have one shaded line segment and one single statement, or statements are pretty much always going to be two shaded pieces and two separate statements. Okay, very rarely, I can't think of many cases in which you would have an or statement that you can write as one single shaded region. Okay, to write this in interval notation, we're going to have two separate intervals. We'll have one for the left side of the graph and one for the right side. So on the left side, we have, let's see, we're starting, quote, starting at -infinity, right, which we can't exactly touch, so we're going to use parentheses, and we're going up to -2, which we can touch because it's a closed dot. Okay, so -infinity to -2, or oh, that's not a bracket, that's a parenthesis because I can get close but I can't touch, 4, and then we go all the way up to infinity, which again, parenthesis because you can't touch infinity. Okay, so notice the difference between and or. And we can write on one single statement and one single segment. When we graph, we're also going to have one single interval, or you're going to have two intervals, two separate shaded regions of the graph, and you have to write it as two separate statements.